My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 120. In this lecture, we will try to understand continuous uniform distribution. In probability and statistics, the continuous uniform distribution is a family of symmetric probability distribution. Because of its shape, it is also called rectangular distribution. One of the most important application of uniform distribution is in the generation of random numbers. This random number generation is very useful in solving many data science problems we will discuss in future classes. Just see this one. Look at this uniform distribution. The uniform distribution is defined in the interval a less than or equal to x less than or equal to b. So the probability density function PDF is f of x equal to 1 by b minus a for a less than or equal to x less than or equal to b. Here b is the upper limit and a is the lower limit. In other intervals, value of probability density function is 0. This f of x is known as PDF. We already discussed in the case of continuous distribution, we used to say probability density function. Whereas if it is a discrete distribution, that is probability mass function. In my previous lecture, I discussed about discrete uniform distribution whose probability mass function is 1 by n, where n is number of trials. This one is probability density function of continuous uniform distribution. Geometrically, one can represent like this. What is this? This is A, this is B, isn't it? Let me say what is height of this particular distribution. This is probability of, how can I say, as he defined, its probability f of x, this height f of x is 1 by b minus a. Means your probability at a is 1 by b minus a. Even probability at b is 1 by b minus a. Probability for every point which lies in between a and b is also 1 by b minus a. Means how many, it will take all values in between a and b, including a and b. Therefore, this is continuous distribution. Means we have probability for all values in between a and b, including a and b. Therefore, I can say this is, what is that probability? The probability is uniform. What is that value? 1 by b minus a. Just find probability at a, this point, this point, this point. Wherever you see every point in between a and b, you have probability. Means here this height f of x. Your f of x is 1 by b minus a. How can I find area of this distribution is also known as rectangular distribution. That's what we were saying in my previous slide. Because of shape, it is also called rectangular distribution. What is the area of a rectangle? Length into width, I can say. What is my length? This one is length, this one is length. This one is, I can say, width. What is my length? Length is b minus a. What is width? What is this width? Width is 1 by b minus a. Therefore, area is 1. Therefore, area of this particular rectangular distribution or continuous uniform distribution is 1. Now, mean. What is the mean? Mean is a plus b by 2, where a is lower limit and b is upper limit. Standard deviation is b minus a by root 12. Now we will see one problem. What is he saying? F of x equal to uniform probability distribution over the range 2 less than or equal to x less than or equal to 6. F of x, what is A? My A is 2 and B is 6. He is saying uniform probability distribution. What is uniform probability distribution? F of x equal to 1 by B minus A, where B is upper limit, A is lower limit, isn't it? Therefore, 1 by B minus A means what? 1 by B means 6, A means 2, 1 by 6 minus 2. That is 0.25 for each value in between 2 and 6, including 2 comma 6. Let me say this is 2, this is 2, 6. Every probability of every point in between 2 and 6, that is 0.25. That's why it's a uniform distribution, isn't it? Therefore, what is the meaning of 2.5? This 1 by 6 minus 2 means what? 0.25. What is the meaning of 0.25? I can say probability of any value, that may be probability of 2, probability of 3, probability 4, probability of 5 or 2.5. Each and every possible value, probability of each and every possible value in between 2 and 6 is 0.25. That's why it's a uniform distribution. As we discussed, mean of uniform distribution is A plus B by 2, that is 2 plus 6 by 2, and standard deviation is under root of B minus A whole square by 12, that is 1.1547, isn't it? Now, we will try to understand one more simple problem on uniform distribution. Suppose random variable is between 41 and 47. This 41 is lower limit, 47 is upper limit. First we have to find out PDF. What is PDF? Probability density function. That is f of x equal to 1 by b minus a, isn't it? 1 by 47 minus 41. That is essentially 1 by 6, isn't it? This is height. I can say the height of the rectangular distribution, this particular height is 1 by 6, isn't it? That height is 1 by 6. Lower limit is 41 and upper limit is 47. Now, see, the uniform distribution is defined in the interval 41 to 47. Suppose we want to know the probability between 42 and 45. Before discussing that probability, let me calculate mean. What is my mean? A plus b by 2. What is A? 41. What is B? 47. Just refer previous slide so that you can understand. A is 41. B is 47. That is A plus B by 2. Standard deviation is B minus A by root 12. 47 minus 41 by root 12. That's 1.732. Now, we will try to identify, we will try to calculate probability between 42 and 45. How can I calculate probability between x1 and x2? This is a formula. x2 minus x1 by b minus a. Means, for example, this one is my x1, this one is my x2. What is my a? A is 41, lower limit, b is 47. Therefore, what is formula? x2 minus x1 means 45 minus 42. That's what it says. Numerator 45 minus 42. By denominator is b minus a. What is my b minus a? B is 47, a is 41. That is 47 minus 41. That's what it says. 45 minus 42 by 47 minus 41. That is essentially 1 by 2. 1 by 2 means 0.5. Isn't it? This probability, this f of x equal to 1 by b minus a. What does it mean? That's essentially, is it not probability? Probability between 42 and 45. Now, we will try to understand one more simple problem. Just see this one. First, we will try to understand problem. Consider the random variable x representing the flight time of an airplane traveling from Delhi to Mumbai. Suppose the flight time can be any value in the interval from 120 minutes to 140 minutes. Because the random variable x can assume any value in the interval, x is continuous rather than discrete. This is one important point. can be any value. That in statement itself is saying any value. Any value means it can take all values, all possible values. In that case, I can treat it as continuous random variable. Let us assume that sufficient actual flight data are available to conclude that the probability of a flight time within any 1 minute interval is same. This point is also a very important point. What is he saying? He is saying that probability of flight time within any 1 minute interval is same as the probability of flight time within any other 1 minute interval. Means probability is same means I must say this is uniform distribution. According to previous slide, this is continuous distribution. Why? Because x can take any value means therefore this problem is related to continuous uniform distribution contained in the large interval 120 to 140 minutes. With every 1 minute interval being equally likely, the random variable is said to be uniform probability distribution. From previous slide, we know that continuous distribution. From this slide, we know that it is continuous distribution. Therefore, we can conclude it as uniform, continuous, uniform distribution. What is our lower limit? Just read that problem carefully. Lower limit is 120. What is upper limit? Upper limit is 140. But what I need? I need probability in between. According to the question, what I need probability in between 120 and 130. I can say I need probability in between 120 less than or equal to 130. I already discussed a formula on this. How can I calculate? This is x1, this is x2. x2 minus x1. What is my x2 minus x1? 130 minus 120 by b minus a. What is my b? Upper limit. My upper limit, this is upper limit 140. b minus a, this is my lower limit, that is 120. That is 130 minus 120 means 10. 140 minus 120 means it's 20. That is 1 by 2. I can say that is 0.5. So what is my conclusion? So the probability of flight arrive between 120 and 130 is 0.5 means that is 50%. This is simple problem. First try to understand problem statement carefully. It is simple. This is x1, this is x2, this is a, this is b, this is continuous distribution. Therefore, f of x1 less than or equal to x less than or equal to x2 equal to x2 minus x1 by b minus a. This you can understand. It's simple and straightforward problem. In next lecture, we will try to demonstrate this particular distribution with simple example. Thank you very much.